Good morning. My name is Serguei Sokolov, and I'm a member of SBS Solution Architecture team. And I'm here today to present you the work we have done in integration of AUD with leading mobile solutions. For that, in our agenda, we want to cover solution architecture of SBS intelligent design solution, and we'll introduce you to Utility Data Hub mobile component and also design container, which is kind of plays important role in integration between AUD and mobile. We'll look at typical design workflow and see how mobile applications can be leveraged to better support the design process. And at the end, I'll present you a few implementation from leading providers of mobile technologies, including Azure, Critigen, Locus View, and Autodesk. I'll start just stating obvious. Automated utility design is used in different domains: gas, electric, telecom, water. And all those utilities may choose to deploy different mobile applications that just address their business requirements. So with this in mind, SBS, we've developed a Utility Data Hub framework that can be configured for specific workflows and applications. So our integration framework stays kind of neutral, as there is no way for us to predict what applications would be required in the field and kind of workflows we should support. In fact, we expect field users to use many applications, so that's kind of in this diagram, not just one, but a huge field application that does everything. And if I think about how I use mobile application in day-to-day life, I've, for example, have changed my mail application, mail mobile application 3 times before I settled on the Microsoft Outlook to receive my emails. So my process has not changed. I'm still reading my emails, but I'm using different application. So with this SBS approach to build the product is we really focus on building a framework that's capable to be configured with the multiple selected mobile application. And also we work with leading vendors, providers of best-in-class mobile application to ensure that the configuration works. Let's look at technical and architecture details, and from architecture team, so I can't like not to show you this slide. The key part is that I'm trying to communicate how the data flows between 3 systems: AUD in the center, work management such as SAP or asset management, Maxima, etc., and GIS. But we focus today on integration between AUD and field, and that involves 3 major components. Of course, I've mentioned Utility Data Hub mobile component that is a plugin for AUD and is part of Utility Data Hub framework. And then there is of course, a important component in architecture for field application. That's a field client, and in many cases we see mobile server that's required to get packages to deliver to field mobile application. And also important component is the design container, and we configure that design container as a media to communicate data from design to a field mobile application. And we use it to deliver a full bi-directional integration, construction packages, design features to the field, and then get all the markups, site conditions, taking other data back to AUD design. One more thing I want to highlight is you can see there are different users. I put a designer in as the one of users of the field mobile application, and the other field users like typical crew. And the reason is we believe that integration with a field and allowing designer to work in both in a seamless fashion in the office, in the field, really benefits the process. So let us look at the typical design workflow, and what you see is the design in the center swim lane, and we've separated as two lines. One, activities done, steps done in the office, and steps done in the field. Designer may start the work in the design application, collect data in the field, and bring it back. So the collaboration and the work seamless data flow between field and office is important for design workflow. That's our SBS best practice. But of course, there are a different school of thoughts, and we've seen implementations that just focus design only done in the field, or other extremes that's design done only in a field. But as I stated, SBS best practice and recommendation is build a workflow that allows you to leverage field mobile application in the different states of the workflow. And for this session, we will focus on field steps in the process that involves researching, the construction, and as-building. I'll go over quickly, just describe key steps in the process. So the design process starts with initiation design, and an AUD user can connect to list work orders, bring in all the data from civil survey data and from GIS, and create perhaps an initial sketch of design. Once this is in a state where it requires some additional input from the field, Utility Data Hub Mobile can be used to publish that design work order data and initial sketch of design to design container. And Mobile Solution Server will ensure that data is delivered to mobile application. And it's also provides ability to visualize design in web applications. So in this case, you see the same design is viewed as published layers in ArcGIS Enterprise. So the other stakeholders can view and access that design data. Now it's back, designer can go to site and do site assessment and data collection. What's really important is that they're in the field, designer not only validates existing features, that's a part of site visit, but also has the opportunity to collect design constraints that it may impact design. So, for example, certain soil conditions that would prevent proper construction, or can actually place a real position of the key design features with a high accuracy GPS receiver. And all that information about points and constraints going back to the design office. So in the mobile application, we expect press button and data synchronized back to design container or goes back to designer. And while I'm back in office as designer, I can open AUD and overlay all the features, materials, and information I collected in the field. So there might be additional location for specific location where I want the service point to be, areas to avoid, like a tree that will not be allowed to cut, or other design constraints. So I can see it. I can actually use AUD to automatically transform those captured points, lines into AUD intelligent features. Complete my design, and once it's done, I press a button with utility Data Hub Mobile to publish now completed design and the materials from construction package to design container. Now we transition to next step, the construction in the process. Of course, it's been approved, construction is done, and now it's time to do as-building. And of course, we want to leverage a mobile application at this stage. It would allow us to review construction package, view construction sheets created in AUD, and basically do the validation of construction using materials CUs, everything what's available as published from design. And we can do also as-built data collection. We know that during construction, certain constraints in the field may prevent construction crews to build as designed. So there may be changes, and those changes can be captured in a field application, plus also for asset tracking. When construction crews install asset, they may do barcode scanning and just capture specific IDs of installed assets, and all that information, all that changes to design and additional information captured in the field can be packaged and saved and goes back to either designer or next step in the process for publishing, updating system of records like GIS or Enterprise Asset Management System. And that's the last step where, in this case, we show how GIS technician would use collected in the field records, in this case, as the value of scanned asset ID to update the GIS and using Utility Data Hub Playback Manager. So that's, I quickly went over key steps in the process of end-to-end process with that leverages AUD as a design tool and with a tight integration with field mobile applications. And I want to transition to just do demos. But before I do that, do we have any questions or any clarifications from the team?
Yes, we do, Sergey. We have a question. What elements of the full Office version are not available in the mobile version? Do we have capability of running engineering checks against configured rules in the field?
There are a couple of questions, and they're great questions. So let me answer. I'll start with the second one. Typically, in SBS Intelligent Design Solution, we try to leverage best capabilities of tools and the products in the workflow. So AUD is a system of record, and it has all the rules configured, and that's what we recommend using for validations in the field. There are certain constraints set by mobile application, but there is no really process of running or validating design in the field. What we recommend is certain changes that may impact the design done in the field, we provide through the interface collaborative kind of way of working with the field. And in AUD design, all the data can be freely moved back and forth almost instantaneously. I can see the changes done in the field in AUD, and I can collaborate with the field as a designer, run the validations and confirm the change. So that's one way of solving this problem. And the second question was around versioning, and it depends on the implementation of the mobile technology, and we will see certain frameworks that support versions. But in our framework, Utility Data Hub with AUD, we don't really trying to keep designs out of versions created in GIS. So design is a system of record for all changes, and it can stay outside of GIS, and only version should be created when the time is right. So when in the process, when construction and then with energized, and now there is a point in the process, that's where we need to update the network. That's the playback manager can be used to create a version and automatically update GIS. So versioning is really not part of the design workflow and typical implementation. All right, I hope this answers questions. If not, or need more clarifications, please feel free to submit those using chat window. I'll continue in the next section of our session. We will look at implementations, and we'll see some demos of real-world mobile applications from leading vendors, leading and mobile technology vendors. I'll start with integration with Esri ArcGIS, and there are a couple of ways of doing it in the mobile using web and mobile applications. I'll present all interfaces in the three kind of key elements: what the interface is, how it's implemented, what are the key components, and what workflows are supported with this specific mobile framework. So for ArcGIS, Utility Data Hub Mobile allows us to integrate bidirectionally with field mobile application and web applications using Design Container. And Design Container for Esri is implemented as ArcGIS enterprise portal, and so the design features and the construction packages are available as layers in ArcGIS enterprise hosted feature layers. They are not features in GIS. That's important. There is no really upload to GIS. These are just layers and the hosted feature layers in ArcGIS enterprise with the published information from design. And as we talked on the session on Tuesday, in the PUG session related to Playback Manager, Design Container allows not only to collaborate and integrate with the field, but opens door for all other systems and the stakeholders, users, to connect to Design Container and see work and see and perhaps analyze the changes done in design. Workflows, it's bidirectional, allows to do pre-design, so when field data is connected, construction and as-built. This is just examples of using web mobile applications, and in this case, work polygon in AUD, we can attach to the feature, polygon feature, construction prints, bill of materials, and the standards. So in a web application on the mobile client, I can select work polygon and view the bill of materials or construction sheets as related. So it's kind of nice and easy way of visualizing data. One of applications provided by Esri is the field maps. This is what Esri now recommends as the main access to all the field-related data, and fully supported with UDH Mobile. It allows users to capture GPS location, field conditions, so do barcode scans, and edit existing features. In this case, you'll see a diagram, screenshot showing all the captured critical locations. That's done in as a field maps. That's another example of using published design data on iPhone application. Quickly going over how field maps can be used in the end-to-end process. So I'm in AUD, created design, and in this case, I'll assign a specific CU automatically set by AUD based on construction standards, and CU is the electron. I published with Utility Data Hub Mobile to design container. I can visualize in the field data, same design. And once I install the meter, apparently I may not have exact same model, same CU, but comparable in characteristics meter, or I just want to scan meter ID. I can do it in the field maps, capture that information with a scanner, and at the end of the day, when the data is published to design container back in GIS client, as a GIS technician, I can see that I not only have data coming from design, but also have as-built values coming from field maps in this case. So I can see existing value, design value, and the field as-built value, and all the comments. And as a GIS technique, I can make an educated decision of what to be, how the system will update my network. So it's a very, very nice way of kind of addressing some of the challenges with as-built-in backlog. And mobile technology can be key to do that, to address that in a digital workflow. Now we will move on and look at LocusView mobile technology. LocusView really provides a technology that integrate. It's not just a mobile application. It's also technology that provides seamless integrated workflow for the entire construction process. And if I would stress the key capabilities of that delivered by mobile technology from LocusView is that they really provide good work in integration with mobile application, with high accuracy GPS receivers, barcode scanners, and they also focus not just on one capturing the updating attributes. They're really looking at way of solving the problem in asset management. So they can review in a mobile application assets and do validation and reconciliation of different asset attributes in the end-to-end process. And architecturally, the way we've integrated with LocusView, our interface, we use as a design container SQLite, which is a part of AUD and can be published as a design container. And this design container is consumed by LocusView digital construction management platform, and it made it available to LocusView web and the mobile applications. Currently, it's configured to one way, but it's just current implementation. We're looking at and discussing different types of workflows. So there's a quick way of how you can publish to AUD design to LocusView, or basically create design container as SQLite. So Utility Data Hub Mobile provides a button to extract this SQLite and synchronize it and put it in a folder for synchronization. Next, LocusView look at end-to-end process. It's more of we look at web enabling application, or we can look at provides also construction support in on the mobile. This video segment presents you Locus View mobile application. Users can search for work orders. Of course, they can visualize design in a mobile device, and they have a concept of work locations as well supported, so there's work units. And for each individual asset, users can look at, do different steps in the process, do as-builting, or add unplanned features, like in this case, attributes been updated, and as the next step, using GPS positioning system external, the user can add unplanned or something that was installed new asset in the field. And the Locus View mobile application provides nice user interface and allows just to basically select from material catalogs and digitize, place those assets that are missing or changed by construction. And that's very important. The way this design container implementation allows us not only to share the design features, but also material catalog, and so the user in the field would use exact same materials and to update attributes as required. Okay, so that's Locus View implementation. We move on and look at Critigen a little more. Critigen provides integrated process with Lemur mobile application that can collect, of course, markups, sketches, do GPS points, all those great things that we expect from a best-of-breed mobile application. But also, one of the things that I would highlight, Lemur technology and what Critigen done is they provide a cohesive workflow with SAP Asset Manager. So that basically creates an environment where two applications work on mobile device in a seamless fashion, exchanging data, and that becomes quite critical. So out of the box, SAP Asset Manager allows to do asset attributes, updates, create and manager statuses on work order, and Lemur works as a plugin, or at the same time allows to link seamlessly map view with the work order. So our interface is using design container layers implemented with ArcGIS Enterprise, and the red lines really represent our integration implementation with Lemur technology. And on the client side, you see Lemur running side by side with SAP Work Manager connected and updating work and assets in SAP. There is also Lemur Hub that is required to create those packages and upload to Lemur application. Critigen supports with Lemur different fieldwork patterns. Some of them are obvious, like look at the location of features. There provides real flexibility, so there might be multiple work orders in this location, so you can zoom to work order and see how many different design going on, or there may be forestry working work order, and there may be design and in the same area, and you will see on the map both work orders and can zoom back and forth from map to work order, from work order to map. Of course, there is a correction of asset location, just update attributes, but we will look at ability of using Lemur in a pre-design. So this video segment shows Lemur client accessing either live data stream or capture it and saved for offline use maps. And once the switching back to work orders, user can see different assigned actions. So I can click on different actions. I can do the as a part of the work order activities. And next we will show how to create a poll location, something that we discussed as a part of pre-design. I know that's where I would like pole to be constructed because of soil conditions, to avoid rocky area. And in a field application, I can capture materials, put desired height and class, it's all the attributes, and then save this data back. In the same fashion, there are quite a few tools available to capture location of proposed range and additional attributes of that range, do markups, do dimensions, and once the field work is done, then the synchronization goes back to design container, and all that great information captured in the field is now available in AUD, can be retrieved from AUD. So next, we look at AutoCAD Mobile, and there is a Utility Data Hub EIM provides integration with Autodesk Construction Cloud these days. So if you have configured it, you can easily upload data to Autodesk Construction Cloud. And one of applications available from Autodesk is AutoCAD mobile application. And I'll quickly just show you, you open AutoCAD Mobile and navigate to your folder with your design. And you probably have seen this design presented by Dave Wilbur as part of AUD overview. And now we can do just use the commands to do snapping, sets proper snapping values, and use AutoCAD to do some as-built changes. So if transform has been installed lower, like 5 feet lower than it was by design, I can just in the field use mobile application, move it, and that will be synchronized back to design. And that's where we need to decide if that's critical change and do validation in the field, or can place additional devices or capture screenshots of the location, or review the construction package and these construction sheets. So this is part of what AutoCAD Mobile provides. And also you can leverage the BIM 360 viewers and integration, as I mentioned, with the construction package and designs to be posted to BIM 360. And there are quite a few ways to visualize specific designs in the content of geography. So that's supported by BIM 360. And of course, Autodesk is solely focused on the construction workflows. So you can create RFIs, submittals, track design, construction issues. So some of those may be important for you if you're thinking about mobile application. It just shows different ways of visualizing. In summary, as we discussed, there are quite a few potential mobile solutions available, and we work with the leading vendors, leading technologies, and we encourage you to utilize those in design and construction workflows. Utility Data Hub Mobile provides a framework of flexible configuration, and you have seen examples where we use design container to integrate with other systems. And it's really important to be configurable because of nature of mobile technologies. They may update, change, and you want to stay, ensure that the workflow and user experience are maintained. And Utility Data Hub for mobile gives you that flexibility with the configuration. And we welcome your input. So this is very important for us. And do we have any questions, Dennis?
Yes, we do. We have a question, have you done any integrations with ArcFM Mobile?
ArcFM Mobile, I'm not familiar with ArcFM mobile application, but we have done quite a few integration with ArcFM technology. We understand how they package data, so I don't see reasons why we can't configure the information to be published in a way that it can be consumed by ArcFM mobile application visualized in the field. This is part of, we need to dig a little bit more deeper in how this can be done, but I think it's possible.